Hey you! Have you thought about what could happen if bad people get your private data without your consent? What if those people had access to military information? Or even worse, what if they knew that your mom is still calling you my baby when she texts you? Don't panic! To save us from that exists the cryptography. Cryptography are the techniques of encoding information so that no one who is not authorized can see the message. This works when at least two people want to send secret messages and have a common key which decrypts a coded message. Right now, cryptography uses mathematical methods incredibly difficult to solve even with supercomputers. But there are a lot of smart hackers who can break these systems. This method is not 100% safe. Also, the growing computer power and future advances like quantum computing will make this method obsolete. To keep our world running, something stronger needs to replace actual cryptography. This could be quantum cryptography. Quantum cryptography uses the principles of quantum physics to make keys 100% secure. The elementary particles studied by quantum physics have very interesting properties such as Heisenberg's uncertainty principle, which says that the simple measuring the properties of a particle will cause a disturbance of its original measurements, or the quantum superposition and the wave function collapse. What? Okay, imagine that this toy Tomatodo, take it all in English, is an elementary particle. This toy has 8 faces and while it spins, it is in its 8 faces at a time. But when someone observes it, the toy collapses and chooses a face. The same thing happens with electrons or photons. Quantum cryptography uses photons, particles of the light, polarized. This means that they vibrate in direction rectilinear or diagonal with value of 1 or 0. When we want to measure the polarization of these particles, if we use a rectilinear detector and the particle has a rectilinear polarization, it will pass without any change. But if we use a diagonal particle with the previous detector, the particle will change to be rectilinear. 50% vertical probability and 50% horizontal probability. If we change to a diagonal detector, rectilinear polarized photons will change to diagonal, and diagonal photons will keep his polarization. Now imagine that I send you a message. I must first send you the key with the photons that I previously measured with random detectors. Then you measure them with other random detectors. We compare our measurements and take the numbers on what we match like the key. If an intruder measured the photons, most probably change them. So we will realize and we won't use that key. All this is just a theory. In practice is much more complicated and costly. However, imagine how powerful this technology will be. Quantum cryptography is based on the laws of physics, and to this day, no one is able to break them.